Hey there, Josh.
Hey, Johan.
How are you today?
Doing well.
Good.
How about you?
I'm doing fine as well. And I hope everyone else is outside as well, doing fine and ready for some learning. So let's see if we can get the slides up running. And remember, this is live and interactive. So feel free to ask questions in the chat. Some of the questions will be answered by me and Josh, but we also have some extremely skilled moderators in the chat that will probably be able to solve all of the questions coming into us. So let's see. This is of course a chain of different events. So we have the third iteration now of learning SQL on Fabric, and this is using AI and SQL's vector functionality with the SQL database in Fabric. Then on the 10th, you will have GraphQL coverage. Then we'll do application lifecycle management on the 11th. And on the 12th, you can get to see the developer-centric query and performance monitoring. And all on that on the screen, as you say, aka.ms, learn SQL on Fabric. And of course, we are, or some are going to Las Vegas on March 31st. If you haven't signed up for the FabCon yet and you want to go, it's a good time to get that booking in now when the early bird discount is still on. And if you use the code word MSCUST or MSCUST, you will save additionally $150 off the price of the early bird registration. And you can see that registration link as well there. Right, Josh, let's take it on to AI integration.
Yeah. So hopefully you're here to learn about how AI can be built on top of these platforms. You may be wondering why SQL for AI, given maybe the history of where you've seen this before. Why would we want to put some of this AI systems on top of our data in SQL? In this case, SQL databases on Fabric. We have vector and knowledge graph databases already out there that support this. So why would we bother going and using a different technology for this? And most of this is all built around this concept that AI applications have very similar requirements to your typical usual applications that you have been building historically. And your organizations or your teams may be more well versed in, say, SQL Server than other technologies that support these. And so why not look at these platforms and say, can we move our data in these, in vectors or whatever it may be, into SQL databases on Fabric to be able to support these AI applications? That way I'm not having to go out and spin up resources that I may not have the skill set for or the capabilities to maintain, while also ensuring that I still have a platform that I know is reliable, scalable, and secure. And we'll talk throughout this about some of those benefits and how this kind of plays into your data strategy going forward. So, if you attended Ignite or watched virtually, you saw that SQL databases on Fabric was announced. With that came some of these capabilities around vector search capabilities and stuff such like that within these platforms. Whether it's Fabric SQL or SQL databases on Fabric, Azure SQL, or SQL Server. All of these capabilities exist there today. You'll be able to put these AI workloads on top of this. Again, as we talked before, you've worked in SQL Server long enough, you know that these platforms are secure, scalable, reliable, and we're now going to be able to, and through today's demo, show you how you can support these AI workloads native within SQL. That way you don't have to go and build this stuff out. And then we start to talk about things like, why would you even want to do this? Why would you want to point AI to this? And it goes kind of this concept of data gravity. So instead of moving your data to AI, why not move AI to your data? If you work in the data engineering ETL space, you understand the effort to be able to get this data moved around. And that increases cost, increases complexity. You have dependencies that you now have to account for. So if I need to make a change, what is the impact to that? And if we can store our data in a single platform and then just have AI on top of that, then it eliminates some of that risk, and allows you to just kind of scale and extend as needed rather than having to worry about moving this around. And you'll see as you work with some of these tools, or platforms within the Azure ecosystem, things like Azure AI Studio, you can connect to things in Fabric without having to go through and move this data around. So when we start to talk about building scalable AI applications, we're going to kind of talk about these three capabilities. So you have vector search, RAG patterns, and then structured queries. And the goal always is to try to find kind of a unified approach to doing this rather than having to support this with different layers. And, so like with vector search, we're transforming like unstructured data into numeric representations, and then we're using that to find similar data using like next nearest neighbor algorithms and stuff like that. And before this, we may have to store that in, say, a different appliance or different platform just to handle that vector search capability. And then we have RAG patterns, which, if you've been following AI and some of the use cases around that, RAG patterns shouldn't be a new thing. But we're basically using some retrieval mechanism to pull relevant data from, a large storage layer, whether that could be images, PDFs, so forth and so on. And then we're using that data to then generate some response that's coherent, that is well informed and naturally articulated. So, think of things like ChatGPT. I need to ask a question about documents that live in a store and then retrieve some meaningful value off of that, whether it's, I'm generating data for claims data or SOWs if I want to auto-generate SOWs for work that I'm doing. RAG patterns would be a technique for that. And then if you're a data professional in general, you should be used to structured queries. So I have data in a structured format. I need to retrieve that data using a defined predicate, straight T-SQL, if you will. This is something that you've been doing for years. Well, why not do this in a single platform rather than having to worry about syntactically they're different? I have to go to different platforms to be able to retrieve this. And so by storing these data types or images or files in a single area, it makes retrieving this a lot easier, and it allows you to build these applications in a more efficient manner. Now, that was kind of quick, but first off, we need to go through, to be able to even access this, we need to deploy AzureOpenAI on our system. So we're going to go through a quick demo of this. So we're in our Azure portal. We're going to go first out and create a resource group. That way, everything that we build out within this resource group, we can monitor for cost. We can, manage this a little bit more efficiently. So if we have all of this in a resource group, I can go there first to find all the things that are tied to this. We're going to add a tag setting the owner. That way we know who owns this appliance or this system. So we can go talk to them if we need to make adjustments or discuss cost, whatever it may be. So now that we have that resource group created, we're going to go out and we're going to create a new resource. So go to that create pane. We'll go into our marketplace. We'll search for OpenAI. We're going to select Azure OpenAI, and we'll create. It's going to display the subscription and resource group. Make sure those are selected appropriately to what we just created. We're going to build this out in ECUS. We'll give it a nice friendly name. We'll set the standard pricing tier, and then we'll hit next. Here, we'll handle networking based off of your needs. We'll go in and add a tag again. So we're going to go set the owner again to the same value. And then we'll get that review pane that you see anytime that you build out a resource in Azure. We'll hit create. And it'll go through that deployment mechanism. You'll get that kind of status page to see as this rolls through and deploys where it's at within the process. So now that's completed, and you see that it didn't take long to be able to do that. We'll then go to that resource. We'll see some information about it, what location it's in, any endpoints or keys, what subscription it's in. We have different options in the left-hand pane around security and monitoring this. We're going to go into the Azure OpenAI Studio. This is where we can define models, deploy models within the Azure OpenAI ecosystem. We'll go into the model catalog. So this is where we can select the models that we want to be able to deploy. And so you have a lengthy list of these, whether it's OpenAI's models, we have DALL-E models, we're going to select a text embedding model, and then we can deploy that in our Azure OpenAI resource. It'll give you a deployment name. You may want to rename that based off of what you need. Maybe you have a couple different options, but we're going to leave that alone and deploy it. We then get some information about it. We also get the target UI to this endpoint, as well as a key for this. That way we can leverage that model within our solution. All right. With that, I'll hand it back over to Johan to talk about vector databases.
Yeah, I mean, I had to admit that I didn't know a lot about vector databases until a year ago or so, when I started understanding it was a lot more important for AI than just putting in a machine learning model somewhere. So first of all, what is a vector? Well, let's put it this way. When we are describing something as humans, we would typically put in an ordered array like this. So defining, say, a dog, well, we think about the height of the dog, how much it weighs, age of the dog, does it have a long fur or short fur, curly fur, how much energy does it have? And for a puppy, that will probably be a lot. But an AI model doesn't work that well on understanding pure text like we do. They have to think in mathematical terms. And a vector is basically an array of numbers, which is a fixed length. And that vector is typically seen as dimensional or a mathematical representation of a point in dimensional space, basically. And we use these in AI to make that understand and work with the data that we have, the unstructured data that we have. So for an AI model that has generated vectors on top of the arrays that we have already generated. So for a dog, that would have been like this, 0.9, 0.3, 0.2. That doesn't necessarily mean anything for humans, but that's the way that the machines work. And then you have the same kind of arrays for an image of a dog, an image of a puppy, and so forth. And then you get the same thing with I took the dog for a walk. That will also be seen as a numerical array that they can then start working over and start comparing again, because they are comparing things and using mathematics. They represent that text string as an array of numbers, and you can use that for the AI. So in this case, we are doing a similarity search, and you can use cosine for that. And when you're starting to look into this, you calculate the different arrays, and you see the cosine saying, okay, 0.4, that's not similar. 0.6, probably not similar either, but it's closer. And this way, the model can start grouping together text strings or representations that are closer together and that might match what the search engine or what the searches are asking for. And vectors this way will make the AI work faster and help improve the functionality. So in this case, we have a similarity range from -1 to 1. And then -1 is that it's identical, and 0 is orthogonal or no similarity. And then you have the 1, sorry, 1 is identical, -1 means that they are diametrically opposed. So this is, yeah. And then you have, when you're getting closer to 1, you have very similar. So it is a way of, again, helping the AI calculate and retrieve data that is quite similar. And why should we use this in a relational database? Well, again, typical is search. So you calculate in equality search on, okay, what do I want to look for? Well, I'm looking for a restaurant, and that's typically what I want to do in Seattle. So I'm looking for something in Seattle. But I accept some travel distance, so well, let's say a 5-kilometer radius, and then we're doing geospatial calculations. And then I want something that is a family style, and then we'll use regex on that to filter down. I wanted to have nice reviews and enough reviews, so it's just not the owner and their family that rates this, and so on. You can also do like, well, probably I'll use Google or something like that and say, okay, I want cheaper restaurants, and then you'll add the price tag into that. And all these things together make sense also, not just in a non-SQL or NoSQL database style, but also in a traditional relational database. Oh yeah, and looking at Teriyaki on there, of course, as well. So all these things together, and this is where the generative AI comes in. So it does the similarity search on all the different things added, and that improves that search mechanism a lot, because what is teriyaki? It might not be very easy to understand from just a regular search expression. So, as Josh mentioned, the vector support in Fabric SQL and in Azure SQL was launched in public preview at Ignite, so a couple of weeks ago. That means that you can get access to it and play with it now by enabling, as we've talked about earlier in this series, if you enable preview features in your Fabric tenant, you will get access to things like this. Documentation is there, but of course, bear in mind that this is in preview, which means that things might change and things might not work exactly as we would think it would. But it means that you can create procedures such as this. You declare a vector, and you execute the stored procedure for get embeddings. Get embeddings will then pull out embeddings from an external source, and then execute that and add that SQL combination in there, where you have the select sub 10, and you use the cosine calculation to pull out the different searches for the distance, and then you do the same thing, or you order that by distance when you're retrieving the search. So this is a hybrid search approach. As you can see, there are several different vector commands that is now then being launched into T-SQL. So you have the new vector n data type. So the vector n data type is a numerical value and a numerical array. Then you have cast as vector to give you that give a string value over to a vector value. You can do a cast as varchar max if you want to have a string equivalent from a vector. And then you do the vector norm to measure length and magnitude of a vector, vector normalize to scale the vector, and vector distance to have the cosine distance between two vectors. There might, of course, be changes, there might be additions, and so on going forward. And typical use cases for vectors in databases like this is the hybrid search, the one we're seeing now, where you embed the semantic search and with full text search and filters. So find, as it says here, find all the documents from Acme customer written by John Doe that are related to the new security policies. Then you have chatbot, and chatbots can store their memories and their chat history into vectors, which means it's easier for them to retrieve it later on. For retrieval augmented generation, and this is the project that we're dealing with in this series. I mean, it's not today's project, it's this series where we're building this app for a conference where we're adding the speakers, their abstracts, combination of those, adding that to the full text search. So the hybrid search also then adds value in the app that we'll be building later on for the audience to search for sessions that they want to attend at the conference. And of course, you have natural language to SQL, which is the SQL Copilot that everyone is hopefully enjoying and working with. And this will, of course, also come in SQL DB at some point, I guess. So it's again, nice to play around with. Then let's see how that can start working. So first of all, we will need to create or select a session database. We've done that. Now we're going to create a credential. And to create that database scope credential, first we need to point out the endpoint, and that is from the target URI that we've created in the when Josh created that OpenAI model. We'll point that in here, but we don't need the full text, so we'll remove everything after Azure.com. Then we need to get the API key, and again we go back to the OpenAI model, and we copy the key, and we paste that into the key portion of the API here. Yep. And then we run this so we can generate the credential. Will take some time. And we're done. Right. All good. Scope credential is here. We need to copy that name because this is the name of the credential. We could have put anything there really, but it's easier. Then we go up to the get embedding part. We'll point in the endpoint name. And then we will, just verify that it is correctly. It is the credential endpoint name. There we go. Then we'll run this, and this will then go send off the data into to OpenAI, return the vector embeddings. So the embeddings are ready-made vector arrays that we will then add into the various tables to get the embeddings inserted into the database. So here you see one of those. Right, and then we will probably... No, yes, that was done on that one. Then it's Josh's turn to use that data.
Thanks, Johan. So now that we have our connection to Azure OpenAI service, now how do we interact with this? So for this next demo, we have a notebook. This is Visual Studio Code, which will allow us to run individual cells to make certain calls, whether it's installing a package, instantiating a connection, and then creating some procedures. And you'll see this as we kind of walk through this. So again, we have this notebook to create these vector supported objects in our database. We're using this notebook. We're going to first go out and install this package. So we're just installing the SQL Server package into our environment. We then need to connect to our SQL Server database. In this case, this is going to be our SQL database on Fabric instance. You see that it's just calling a connection and then passing in a connection string. So we go out to our SQL database on Fabric, we go to the gear setting, go to connection strings, and we can get this connection string in various formats. So we're going to go grab this. We then need to plug that into that session database param. to be able to go in. We're using interactive authentication, so it's going to pop up a pane for us to authenticate. Now we're connected, and our session kind of was created under this SQL-session DB. So in that lower right context switcher, we can select the kernel that we created in that session to make sure that we're going to do the next steps against our database in Fabric. So here we have a cell that is going to create a procedure called update session embeddings. We then have another procedure that it's going to update the speaker embedding. So here we're going to pass in a speaker, get an embedding back, and then be able to update that table that stores speakers that have this. We then have a procedure that is update all embeddings. So we're going to go out and retrieve all the speakers that do not have an embedding in the database and store this within it. And then you kind of see that here where we're creating a cursor, which I know is, depending on who you are, is like a big no-no. But, in the context of this demo and ease, we're going to go this. We can then go retrieve this. So, the first thing is we're just retrieving all the speakers that we had created earlier. We see that here are all the speakers that do not have an embedding. And then once we ran our stored procedures that we created earlier to go get these embeddings, we can store that in the database. Now we see that each of our speaker has this embedding. So we don't want to have to run this on some schedule. We want this to be as live as we can. So we're going to create some triggers. That way, as data is inserted into our database, so a new speaker is added, we go out and retrieve this embedding automatically and then store it within our speaker table. You kind of see that here. Again, we're just calling these same procedures. So we have a trigger, get speaker embedding on insert. Again, we insert that speaker into our speaker table and then go and retrieve that and store it. Simple enough. Okay.
Then we're on to
So
the next
now
one.
hand this back over to Johan.
Yep. So we'll start doing some inserts of new sessions into with an existing speaker. But first of all, okay, it doesn't look very good to have just SQL Query 1. So let's rename it, because as you have learned before, the SQL script that we're creating will be stored in the GUI for you. So have a nice name, we'll insert these sessions, and then when we look into the session table afterwards, let's see if we can get some response. Oh, there we are. Now we have 4 sessions coming in, and you can see that we have embeddings, the embedded vectors represented. Same with the speakers, I hope. Let's see. And they have, yep. Right, so let's do some more inserts so we can see if OpenAI will work with these as well. So let's run this. And as you can see, we're inserting rows. Now let's take a look. Only 4 rows. That's wrong. As we saw that there were more than one session or row inserted, quite a lot more. So let's try to close these panes, preview panes. They aren't refreshing properly. And we can start loading them again and double check. Yes, this was better. Let's check, and we've got embeddings in the columns. And I think this is actually a column store index on that's the column, which is pretty handy. So now we can then start querying from this to see. and both of them here. As you can see here, now we've done the vector to JSON array conversion to get that out. And all good. So as you've seen now, we've managed to insert more data. The background operations will fetch the scores from, or the vectors from OpenAI and return that into the table. And we're basically good to go whenever the app is updated with more speakers and more sessions. And with that, I think we are quite about done, Josh.
I believe so.
Remember that all these features are not available in all parts of Azure or the Fabric yet. Not all regions have them. So make sure that you check on which one of them you're deploying in. Otherwise, you might not be able to test this yet. As we go forward, it will be available for more in more regions, and then it might be easier for you to get started. But you remember this is also being recorded. Hopefully round about Vegas time. I mean, Microsoft always loves to announce things around big conferences. So hopefully, if you're lucky, around about Vegas time, this will go into GA. Otherwise, I mean, it's FabCon, Build, Ignite, typically where they launch things. So one of these. And then they'll probably be able to do a more hands-on session of these learn live together. And maybe there will even be a certification on this. Who knows? Microsoft probably knows. I don't. But yeah.
And just to call out, you don't have to have Fabric and built out at your company. Microsoft provides a trial capacity for you to go out and try Fabric for 60 days on this trial, which gives you capacity to be able to run all the workloads across the whole Fabric ecosystem. And so go out and try this if you don't have access to it at your company. Go in and set this up on your personal account and go through all of these workloads that we showed today. You'll see that there's ways that you can leverage Azure OpenAI as well in that kind of same context. But yeah, if you have any questions, make sure to post in the chat and we'll be happy to answer any of those. While we wait for those to come in, we'll just remind the schedule. So, you attended our session this morning or at lunch, I guess your time. I'm based in the US East Coast time, so it's quite early for me. But the next session on this time zone is December 10th on using GraphQL and application development with SQL databases and Fabric. As Johan mentioned, these are recorded and stored in the YouTube channel for the Reactor, sorry. So if you're unable to make one of these, you can always go back and watch this later. You need a refresher, you want to share this with your teammates that weren't able to make this, you can just send them this and go through that.
Yeah. Remember also that some of the PMs that are active in this space, such as David Mauri and Pooja Kamath, have their own blogs where you can see more samples of how to use this. So it's definitely worth checking them out. So David Mauri, sorry, and Pooja Kamath. And with that, I think we can start to slowly roll out. There haven't been any more questions. So just one more slide to go.
Yep.
Once more, remembering FabCon.
Yeah. And make sure to take advantage of that early bird discount, as well as use the code MSCUS to save $150 on that registration to the Fabric Community Conference in Las Vegas. Make sure to connect with Johan and I on LinkedIn. We would be happy to talk about anything Fabric oriented, as well as I should be at Fabric Community Conference, so would love to meet anybody that's there.
All right. Thank you so much for attending, and have a nice rest of the day.